We're all seeing it, right? The AI revolution is here. It is completely reshaping industries, opening up possibilities we never thought of, and honestly, it feels like we are on the ground floor of something massive. But behind the magic, behind every single amazing image and every smart answer, there's a huge physical world being built, and it comes with a truly staggering price tag.
Okay, let's just let that number sink in for a second. $1 trillion. That's what we're projected to spend on data centers, on chips, on raw power just to keep this AI boom going over the next decade. This isn't just a big number, it's the frame for this entire story, this colossal all-in bet we're placing on the future of AI. And that $1 trillion, well, it's fueling what you can only call an AI infrastructure arms race. The biggest tech companies on the planet are in a global spending spree, a mad dash to build the physical foundation for artificial intelligence before their competitors do.
You know, to really get what's going on here, you have to look past the cool software demos and just follow the money. Because this isn't just about some clever code. This is a monumental construction project. We're talking about a physical build-out of data centers and custom chips and power grids on a scale that is just unprecedented.
And this chart really paints the picture, doesn't it? I mean, look at these numbers. Amazon is plowing $125 billion into this, Meta over $65 billion. And then you have OpenAI with this rumored Project Stargate, a $500 billion supercomputer. This is the highest stakes poker game in the world, and the buy-ins are just astronomical.
But here's the twist. Even as these tech giants are spending sums that are hard to even comprehend, Wall Street is starting to get, well, a little nervous. Investors are starting to ask the really tough question. Okay, that's great, but when are we going to see a return on this money? This skepticism, it's creating this new thing people are calling AI spending fatigue.
And the cost isn't just about dollars and cents, not even close. All this explosive growth is putting a massive strain on our infrastructure and our environment. It is a hidden crisis, and it's brewing right behind our screens. This slide really boils the problem down. You know that seamless, conversational answer you get from an AI? Well, it takes about 10 times more electricity than a simple Google search. 10 times, every single time. Now, multiply that by billions of queries a day, and the energy demand just goes off the charts. We used to talk about data center power in megawatts. Yeah, those days are over. These new next-generation AI supercomputers, they're projected to need multiple gigawatts of power. That is the same amount of electricity it takes to power a large city for one single facility. It's a whole different ballgame. And look, it's not just us saying it. This quote from a recent research paper nails it. The incredible power of AI comes at this profound computational cost. The path we're on right now, just building bigger and bigger, more power-hungry models, it's becoming completely unsustainable for the bottom line and for the planet. So, what do? Does this mean the AI party is over? Not at all. It just means we have to get smarter. We need to manage it with intelligence and with discipline. And that brings us to this really important emerging practice called AI FinOps.
So what the heck is FinOps? Well, it's short for financial operations. And you can think of it as a way to bring financial accountability to the wild west of cloud spending. For AI, it's all about making sure that every single dollar you spend on compute power is actually driving real business value. It gets your tech, finance, and business teams all speaking the same language.
Okay, so how does this work in the real world? Well, a lot of it is done through tools like a unified AI gateway. Think of it like a central control tower for every single AI service a company uses. It lets you see your costs, track performance, swap out different AI models with a click, and actually enforce budgets. It's how you put FinOps into action.
But hey, managing the money is only half the battle. The other really exciting part of the solution is making the AI models themselves way more efficient. The race is starting to shift. It's not just about who can build the biggest model, but who can build the smartest, most cost-effective one. And this table is the perfect example. Wow, look at this. For a really complex task, running it 100,000 times on the DeepSeek model costs $70. Doing the same task on another model, over $1,000. That massive difference shows you that cost efficiency is becoming a deadly serious competitive advantage. And this really gets to a core problem everyone in AI is wrestling with right now. It's the law of diminishing returns. After a certain point, you can just keep throwing more money and more power at a model, but the improvements you get in accuracy get smaller and smaller and smaller. Meanwhile, the costs just keep climbing. This phrase just captures the new way of thinking perfectly. The whole game is changing. It's not about brute force anymore. It's about compute-aware reasoning. The best, smartest AI is going to be the one that delivers amazing performance while being totally aware of the real-world cost, both in money and energy, of what it's doing. Okay, so we've talked about managing costs and building smarter models, but there's one last piece to this giant puzzle: your infrastructure strategy. For a lot of folks, this means it's time to embrace the multi-cloud reality. You see, putting all your eggs in one cloud provider's basket is becoming a really high-stakes bet. And there are three big reasons why. First, outage risk. If that one provider goes down, your whole business can go dark. Second, regulations. Data laws are different everywhere, and sometimes you have to use local providers. And third, and this is a big one, negotiation leverage. If you can't credibly threaten to walk away, you have zero power on pricing. But let's be super clear here. Multi-cloud doesn't mean you have to run everything on every cloud all at once. That would be a complete nightmare. No, it means being smart. It means building intentional diversity for your most critical systems. It gives you flexibility, it gives you resilience, and it gives you control over your costs. And so that brings us all the way back to the beginning, to the trillion-dollar question. As we rocket into this next phase of the AI revolution, is it possible that success won't be defined by who has the most raw power, but by who has the smartest, most sustainable, and most efficient economics? The answer to that is probably going to shape the next decade of technology.